Okay, so have you heard about this new development in computing? It's pretty fascinating, actually.
Are you talking about the photonic processor?
Yes, exactly. The one from that German company, what was it called?
QANT?
QANT, yeah.
Yeah.
Seems like it could be a really big deal, like a real game changer, especially for AI and all that.
Oh, yeah, definitely. I mean, using light instead of electrons, that's a pretty radical departure from how we usually think about computing.
Yeah, and that whole thing about it being way more energy efficient, like 30 times more efficient, that's got to be huge, right?
Yeah, if they can really deliver on that promise, it could have a massive impact. I mean, think about all the energy we pour into training these huge AI models.
Yeah, it's mind-boggling, isn't it? I read somewhere that training one of those massive language models can use as much energy as a small town, like over a week or something.
It's crazy, and that's only going to get worse as these models get even bigger and more complex.
Exactly. So if this photonic processor can actually cut down on that energy consumption, well, that's got to be a good thing, right?
Absolutely, and it's not just about the energy savings, it's also about the potential for speed. I mean, some of the articles I've read suggest these processors could be orders of magnitude faster than traditional electronics.
Really? Wow. Okay, so we've got this company, QANT, and they've developed this photonic processor that's supposed to be super efficient and super fast.
Right, and they just recently launched their first commercial product, their NPU, or Native Processing Unit.
When was that again?
It was back in November 19th, 2023.
Okay, so it's still pretty early days, but it sounds like they're already making waves.
Oh yeah, definitely. There's been a lot of buzz in the tech world, and for good reason, I think.
So what can you tell me about this NPU? Like, what does it actually look like?
Well, it's not a tiny chip that you'd put in your phone or anything like that. It's actually designed to fit into a standard 19-inch server rack, which is pretty common in data centers.
Oh, okay, so it's meant to be like a serious piece of hardware.
Yeah, definitely. It's designed for heavy-duty computing tasks.
I've also seen a lot of talk about the energy efficiency, like how much more efficient is it compared to the current technology?
They claim it's 30 times more energy efficient than CMOS technology, which is the current standard for microchips.
30 times? That's a lot. It's hard to even wrap your head around what that means.
I know, right? It's a pretty bold claim, but if they can back it up, it could really shake things up.
And they also say it's faster, right?
Yes, much faster. Some experts say it could be as much as 100 times faster than conventional processors for certain tasks.
That's insane. So what exactly makes this photonic processor so different from the kind of processors we use now?
Well, the key difference is that it uses light instead of electricity to process information. Regular processors rely on electrons moving through circuits, but this one uses photons, which are particles of light.
Huh. That's pretty mind-blowing. So how does that actually work?
Okay, so it all comes down to their proprietary architecture, which they call LENA, which stands for Light-Empowered Native Arithmetics.
Lena.
Yeah, LENA. And the heart of this architecture is a special material called thin-film lithium niobate, or TFLN for short.
TFLN. So what's so special about this TFLN stuff?
Well, it turns out that TFLN is really good at manipulating light. It lets you control and direct photons with incredible precision and efficiency.
Okay, so they're using this TFLN to build these light-based circuits.
Exactly. Instead of having electrons flowing through wires on a chip, they have photons traveling through tiny optical pathways, kind of like a microscopic fiber optic network.
That's wild. And this TFLN makes that possible.
It does. See, silicon, which is what we usually use for chips, isn't that great at handling light. But TFLN, on the other hand, it's perfect for it.
Interesting. So how does all of this translate to the actual performance of the processor?
Well, the increased control over light, it allows them to do those power-efficient mathematical operations that are crucial for things like machine learning and AI.
Oh, I see. So those calculations that normally take a lot of energy and time on a regular processor, they can be done much more efficiently with light.
Exactly. And because they can control the light so precisely, they can actually achieve much higher clock rates than traditional electronic systems, maybe even 2 orders of magnitude higher.
Wow, that's a huge difference. I mean, what would that mean for, like, real-world applications?
Well, for one thing, it could drastically speed up the training of AI models. Right now, training those models can take weeks or even months, and it consumes a ton of energy.
Yeah, it's a real problem, isn't it?
It is. But with this new photonic processor, you could potentially do that training in a fraction of the time and with a fraction of the energy.
So we could develop new AI applications much faster and with a much smaller environmental footprint.
Exactly. And it's not just about AI training. This technology could also revolutionize other areas like drug discovery, material science, financial modeling, anything that requires massive amounts of computation.
So it's not just a niche technology, it has the potential to be really widespread.
Exactly. Now, right now, it's still pretty early days, and the NPU is designed to be integrated into existing data center infrastructure. But in the long term, they're hoping to miniaturize this technology even further.
Oh, interesting. So we could eventually see photonic processors in our laptops and smartphones.
Potentially, yes. I mean, there are still some technical challenges to overcome, but the possibilities are really exciting.
So we've talked about the technology, but what about the company behind it? What can you tell me about QANT?
Well, they're a spin-off from Trumpf, which is a big German company that specializes in lasers and machine tools.
So they have some serious engineering expertise behind them.
Oh, yeah, definitely. And they've been working on this photonic computing technology for a number of years now.
So they're not just some fly-by-night startup.
No, not at all. They're a serious player in this field.
And what about the wider industry? How are other companies reacting to this development?
Well, the silicon photonics market is growing rapidly, and QANT's launch has definitely generated a lot of interest.
Yeah, I've seen some reports projecting that the market could be worth over $600 million by 2028.
That's right. And it's not just about the money. There's also a growing recognition that photonic computing is the future.
So QANT is kind of leading the charge here.
In many ways, yes. I mean, they're the first company to launch a commercial photonic processor, and they're also one of the few companies that can manufacture these processors in-house.
Oh, really? So they're not just designing them, they're actually building them too.
That's right. They have a very close partnership with another company called IMS Chips TS, which specializes in semiconductor manufacturing.
So they've got the whole process covered.
They do. And that gives them a significant advantage over their competitors.
It sounds like QANT is in a very strong position.
They are. And they're not just focused on commercial success, they're also very committed to the idea of sustainable computing.
Yeah, I read that quote from their CEO, Michael Furch, where he talks about sustainability and performance going hand in hand.
Yeah, that's a really important point. Photonic computing has the potential to be much more energy efficient than traditional computing, which is crucial as we become more and more reliant on technology.
Especially with all the concerns about climate change and the environmental impact of our digital infrastructure.
Exactly. So QANT is really pushing the boundaries here, both in terms of technology and in terms of their commitment to sustainability.
It's pretty inspiring, actually.
It is. It shows that you can be innovative and environmentally conscious at the same time.
So where do you see this technology going in the future? What are some of the potential applications that you're most excited about?
Well, I think the biggest impact will be in the field of AI, for sure. With these faster and more efficient processors, we could see a whole new generation of AI applications that were previously impossible.
Like what?
Well, for example, we could have AI assistants that are truly intelligent and can understand us much better than the ones we have today.
Oh, wow. That would be amazing.
It would. And we could also see huge advances in areas like medical diagnosis, drug discovery, and personalized medicine.
And what about other areas beyond AI?
I think photonic computing could also have a big impact on fields like high-performance computing, which is used for things like weather forecasting, climate modeling, and scientific research.
So it could help us understand the world around us better.
It could. And it could also lead to breakthroughs in areas like quantum computing and integrated photonics, which are still very early-stage technologies, but have enormous potential.
It's pretty mind-boggling to think about all the possibilities, isn't it?
It is. It feels like we're on the cusp of a new era in computing, and QANT is right at the forefront.
I have to say I'm really impressed with what they've accomplished.
Yeah, me too. It's a really exciting time to be following this technology.
Well, I think that's about all the time we have for today, but this has been a fascinating discussion.
I agree. It's always great to talk about the future of computing.
And who knows, maybe in a few years we'll all be using photonic processors in our everyday lives.
I wouldn't be surprised.
Well, until then, we'll keep our eyes peeled for more developments in this space. Thanks for joining me today. It's been a pleasure.
The pleasure was all mine. It's been a great conversation.
To all our listeners, thank you for tuning in to our deep dive on QANT and the world of photonic computing. It's a rapidly evolving field with huge implications for the future, so stay tuned for more updates.
And be sure to check out those sources we mentioned. There's a lot of great information out there if you want to delve deeper into this fascinating topic.
Absolutely. Until next time.
See you then.